You might not believe this. I tried to record a video of multiplying and dividing rational expressions earlier, but I ran into a little bit of problem. So let me show you what happened here.
So, as I was saying, crazy, right? Okay, but now I think I'm okay. We're gonna practice this. Remember our exclusions from before. Denominators can never equal 0, so you have to always make sure you state your exclusions. What would make the denominator equal 0? What would cause problems for us? Today we're gonna be multiplying and dividing these things. So remember, when you multiply fractions, you just multiply across the numerator and across the denominator. When you divide fractions, you keep the first, change division to multiplication, and then you use the reciprocal of the second fraction. So check this out. Is there anything we can simplify? You have 6 over a squared times negative 2 over a to the third. Can you simplify 6 with a squared? Nah. Negative 2 with a to the third? Nah. Remember, you can simplify fractions diagonally as well when you're multiplying or dividing. But again, there's nothing we can do here. So we just go ahead and multiply. 6 times negative 2 is negative 12. A to the second times a to the third. Remember our exponent properties. What do we do when we multiply bases? We add them. So this becomes a to the fifth. That's simplified all the way, bro. But remember to state your exclusions. We have to worry anytime there's a variable in the denominator. So, a squared and a to the third. You can set up an equation. A squared cannot equal 0. The square root of 0 is 0. So a cannot equal 0. That would be the same thing if you set up a to the third cannot equal 0. And you cube root both sides, it still comes out to 0. So 0 is the only thing that a could not equal in the original problem. Let's try this one out. A little bit tougher. X minus 7 over x times x minus 5 over x plus 3. Now, do they have anything in common that we can cancel out? Some people will say, oh, x over x, but it's got to be grouped off for you to be able to cancel out an x for an x. This x goes with this minus 7. That's in one little group there. So we can't simplify that with the x. We can't simplify this with the x plus 3. Nothing to do down there. Let's do our exclusions right now. While we've got it a nice pretty fraction, what could this x not equal? 0, right? This one, x plus 3 cannot equal 0. So if you subtract the 3, then x could not equal negative 3. Those are our two exclusions. X cannot equal 0 and x cannot equal negative 3. Then we go ahead and we just start multiplying stuff. Sometimes people like them factored out for their final thing. Like they would write it just x minus 7 times x minus 5 over x times x plus 3. Some people like it like that. Depends on what your teacher's looking for there. Great. Some people like you to actually FOIL it out and distribute. So if you do first, outside, inside, last, x times x is x squared. Outside, x times negative 5 is negative 5x. Inside, negative 7 times x is negative 7x. And last, negative 7 times negative 5 is positive 35. If we clean that up a little bit, like terms, negative 5x, negative 7x gets you negative 12x in the numerator. So there's our whole numerator. And then we need to distribute in the denominator. X times x is x squared. And x times 3 is 3x. Nothing else to simplify there. Wow! I don't know what's going on here. But, again, you can't simplify the x squared over the x squared because they're in a different group. This x squared is grouped with all this other stuff. If they were both factored out, then you could get rid of them. Come on. And first try, can you believe it? Here we go. X plus 5, 7x minus 21, 14x, x squared plus 3x minus 10. These are nice because a lot of times if you can find one of the factors, it typically shows up somewhere else. X plus 5, there's nothing we can do to factor that. So let's just write it in parentheses. because I bet it'll cancel out somewhere else. 7x minus 21. Any common factors for 7 and 21? Yeah, 7. So we kick out a 7. 7 times x is 7x. 7 times negative 3 is negative 21. Fantastic. On the other part, 14x is a monomial. We can't do anything with that right now. Just leave it. X squared plus 3x minus 10. Two factors that multiply to negative 10. Has to be a positive times a negative. X plus, x minus. They have to be 3 apart. So big numbers gotta go with the plus because our first symbol is plus. So that would be 5 and negative 2. 5 times negative 2 is negative 10. 5 plus negative 2 gets you 3. Let's do our exclusions while we're here. What could this x not equal? It says x minus 3. So x could not equal the opposite, positive 3. This says x plus 5. So x could not equal negative 5. This one says x minus 2. So x could not equal positive 2. There's all our exclusions. Remember, we only have to worry about the denominator. Now what can we cancel out? Oh, I see an x plus 5 for an x plus 5. Let's cancel those out. Anything else? Are there any x minus 2's on top? Nah. All we got left on the numerator is 14x. 14. Anything we can simplify that with? The 7. How many 7's go into 14? Yeah, 2. So we make this a 1, but we don't really need to write the 1. We make this 14 a 2. So let's clean up our numerator. All I got left up here, there's nothing over here. There's a 1. 1 times 2 times x is 2x. In the denominator, 1 times this is just this, x minus 3, and we got an x minus 2. Personally, I like the answer left this way. Again, some of your teachers might want you to actually FOIL that out, which if you did that would be x squared minus 5x plus 6. Both of those answers are pretty sick. Check with who's in charge, see which one they would prefer. I like this one better, but this is me, okay? No big deal, all right? Let me see what else I got, all right? I'm gonna guess we got division. Oh, times a whole number. Every number is technically a fraction, right? Every number, like 2 is a fraction, it's 2 over 1. So if you ever need a denominator, chuck a 1 on the bottom. Whoop. There we go. Now we got fractions again. 2m plus 5, any common factors? No. So just write it, we'll put it in parentheses. 3m minus 6, any common factors? 3. Kick it, 3 times m is 3m, 3 times negative 2 is negative 6. Everybody's favorite song. Over here, m squared plus m minus 6, it ends in minus. Has to be one of each. M plus, m minus, we'll keep the 1 on the bottom. Factors of 6 that are 1 apart, 3 and 2. We use that all the time. Plus 3, minus 2. Let's get our exclusions. M minus 2 in the denominator. What could m not equal? Remember, we don't want it to equal 0. So if you said m minus 2 equals 0, then you add 2. M cannot equal 2. That's our only exclusion. Even though this is going to get canceled out, you got to go with the original stuff. So, I think I just spit all over the place. That's how excited I am. I'm getting so passionate about math, I'm just spitting everywhere. So what can we cancel out? The m minus 2 for an m minus 2. All we got left on the bottom is 3 times 1, which is 3. Can we simplify 3 with any of these groups? Nope. So on top, we've got 2m plus 5. We've got m plus 3. Only thing in the denominator is 3. There it is. Again, check with your teacher. Maybe they want it FOILed. Let's do a division one. Here we go. A lot of factoring, but remember we change it to multiplication and then we flip that second fraction. X squared minus 25, that's the difference of squares. Square root of x squared, x. Square root of 25, 5. So we got x plus 5 and x minus 5. Look at the bottom, 4x plus 28. 4, common factor. 4 times x is 4x, and 4 times 7 is 28. I'm a bit of a rebel, so I'm going to change this division right now. But now this x minus 5 is going to the denominator. And then we look at this, and this is going in the numerator. X squared plus 9x plus 14. Factors of 14 that add up to 9. Your factors of 14 are 1 times 14 or 2 times 7, which set gives you 9, 2, and 7. X plus 2, x plus 7. Let's get our exclusions handled. X plus 7. So that means x could not equal negative 7, right? The opposite. This says x minus 5, so x could not equal positive 5. There's our exclusions. Let's start crossing stuff out. What do you see in the numerator and denominator that we can simplify? X minus 5, x minus 5. Anything else? Yeah, the x plus 7. X plus 7, x plus 7. What's left up here? X plus 5 and x plus 2. All I got on the bottom is 4. So we're all good, playa. X plus 5 times x plus 2 over just a 4 down there. There it is, simplified all the way. Maybe foil it. I don't know. Be a rebel. All right, this is gonna be my last one because I got a class in 5 minutes. It might even be you. I don't know. Remember, everything's a fraction. So we're dividing by this whole number. That whole number is technically over 1. So we're gonna multiply by the reciprocal, which means you flip that fraction upside down. So first part, 3x squared minus 12x. What do they have in common? A 3 and an x. 3x, factor that out. 3x times x is 3x squared. 3x times negative 4 gives you that negative 12x. On the bottom we got 5x, nothing to do there. Yet. Remember, the 1's scooching to the top now. I believe that is the technical mathematical term, scooching. This scooches to the bottom, the denominator. Ends in negative 4. It's got to be a plus and a minus. Your big numbers got to go with the minus because they add up to negative 3. Factors of 4, you got 1 and 4, or 2 and 2. We need them to be 3 apart, so that's 1 and 4. Let's do our exclusions. What could this x not equal? What times 5 would give you 0? 0. So x cannot equal 0. This says plus 1, so x could not equal negative 1. This says minus 4, so x could not equal positive 4. Those are the 3 things x could not equal. Now let's start canceling some stuff out, some like stuff. Oh, x minus 4, x minus 4. Anything else? Now some would say no, but I would say, yeah. What about the x's, bro? We got 3x over 5x. So we can cancel out an x for an x. They're both grouped off. So all we have on top is 3 times 1, which is 3. All we have in the denominator is 5 times this stuff, the 5 times x plus 1.
Make sure that you always circle your answers and try your best, okay? Your teacher needs to be able to find your work pretty quickly, so that's why circling it actually helps quite a bit. They can grade their papers faster, and you can get your results back, and you can grow from that, okay? So, try your best, practice this out, you got this, okay?